Okay, in section 4.3, the next section 4.3, use the slope to show that the lines are perpendicular. Again, just like a previous section, the line passing through the first 2 points and the passing through another 2 points, if they are perpendicular, it's look like this. Perpendicular meaning they are crossing each other with a 90-degree angle. Okay, this is called these line 1, line 2. They are perpendicular. In our textbook, page number 251. The definition there says if two lines are perpendicular to each other, then their product, their slope is -1, or their slope will be negative reciprocal to the other slope. This is a negative reciprocal. It's look like this, meaning one slope is 2/3, another slope you just you just flip over your fraction and then put the opposite sign for that. If this is positive, this is negative. This is called negative reciprocal, or another way you can do that is the product of the slope is -1. Okay, vice versa. Anytime you see the -1 slope of the product, there's got to be perpendicular to each other. Now we are into the example checkpoint number 4. The page number 252. That example show that the line passing through these two points, okay, the first line and the line passing through these 2 points are perpendicular to each other. Algebraically, obviously, when this kind of a problem like this, you know, according to the instruction there says, you do only the algebra. You only show your slope 1 times slope of 2 is -1, or you show that slope of number 1 is negative reciprocal of the second slope. You don't have to graph, okay? Unless they tell you to graph, you graph, because graph is taking a lot of time. You show that you know, the line like this, and no use. Will be you don't get a credit. This problem wants you to only do the algebra, okay? Don't misunderstand the problem. They saw the previous exam. Show the graph, don't get you any credit, okay? Remember that. Now, so we show that this is our slope of number 1, the line number 1 with the slope, line number 2 with the slope of this. So let's check that to see that our product is -1. So slope of number 1, y2, 2, subtract y1, 4. If you are, okay, the other way you can use this as second point, this is first point, okay? That's this time using 4, this one is second point, 4 subtract 2, okay? And then -1, second point, -1 subtract 3. And do this way, will be this equivalent to that way. Okay, this is slope, numerator reduced to 2, denominator reduced to -4. That's -1/2. The first line, this line, with the slope of -1/2. Let's take a look at our slope of the first, the second line. Okay, y2 7, subtract y1 -1, subtract parenthesis -1, and then x2 is 2, x1 -4. Let's take a look. Let's see. 7 subtract -1. That will be 7 plus 1, 8. 2 subtract 6. 2 subtract 4. let's see, 2 oh, 2 subtract negative 2, that's not negative 4, negative 2 here. So 2 plus 2 is 4. Okay? Just need to copy everything correct. My mistake. Now you get the slope, second one is 2. So you can see that it's a negative reciprocal of each other. You can put a 1 down here, you flip over, you put a negative 1, you get this. Or another way, you show m1 times m2 equal negative 1. The minimum is to show this, okay? And then you can make your conclusion perpendicular, okay? You got to make a good conclusion. Otherwise, I cannot, you cannot assume I understand you. You show this, or you can put this and then make your conclusion perpendicular. They are perpendicular to each other. Okay? This is our example for 4.33.